For hanging out with us today as we do a live demonstration of crash scene documentation from our warehouse in California. I am very fortunate today to be joined by Matt, who is part of the Skydio team and has a lot of experience in the world of crash reconstruction. So Matt, you want to go ahead and introduce yourself?
Hey, thanks, Noreen. Good morning, everyone. Matt Borwinkle with Skydio. I'm a solutions engineer on the SLED, which is our state, local, and mostly law enforcement driven team. And prior to that, I spent 25 years with Illinois State Police. And my last 4 years with the agency, I was a supervisor with a statewide crash reconstruction team and helped stood up the drone program to speed up our handling of crash scenes, and very excited to be here with you today to talk about a couple of topics related to crash reconstruction.
Excellent, thanks. And I'm Noreen Charlton. I lead public safety strategy and marketing here at Skydio, but my background is in scene documentation. I was a crime scene investigator with Las Vegas Metro for more than 10 years, and then I dedicated several years after that to helping agencies across the world document their crime scenes for courtroom purposes. So a lot of information to put out there today for everyone. Please, if you have any questions, throw them in the chat. We will answer those either live or at the end of this session. And before we kind of kick off into our live demo, I just want to remind everyone, or at least let you know in case you weren't aware, we did a webinar back in December where we kind of covered what drones can do for scene documentation, for the benefits of having drones, what kind of scenes you can be flying them on, what kind of data you can get from it. And we really focused on our partnership with FARO and FARO Zone 3D Expert software and what you can do with our images in that software. So after the demo today, you will be provided with the images that are captured in this particular demo so that you can use them however you want to, whatever software of choice you want, so that you can process them in photogrammetry or create diagrams or whatever it is that you want to do, so you can see for yourself how it works for you and for your potential cases. So if we can go to the next slide, Kendall, before we kind of kick it off, these are the vehicles that you will be seeing today. These are located in our warehouse in California, and we do have someone over there to fly, and Matt will talk you through the process. So without further ado, Matt, we want to kick it off to Hayward.
Awesome. I'm very excited to talk about 3D capture and how easy and safe and affordable this is to use. So many things you can do with this to speed up the capture of your scene and get accurate representation. So what my partner Dave is doing in the warehouse right now, he's labeling this crash scene. And normally, as a crash reconstruction person, you would want to put your case number or description there of the scene that you're about to capture. So Dave's going to go ahead and lock that in, and we're going to move forward through the mapping menu here. So Dave's about to launch the aircraft. Aircraft's going to do a quick 360 calibration turn, and now he's going to be able to go right into the return behavior. He's going to set the launch point. Now he's going to set the floor. A lot of ways you can do this. You can use the default. Dave right now is setting a custom default. He's lowering that floor below the level of the vehicles there. So by dragging that artificial horizon down, he's able to make sure that the cameras are going to capture everything at the ground level, all the way down to the wheelbase. So if there's any crush damage along the side, that's going to capture in each one of those photos there. So now Dave's going to set the ceiling height, and all he has to do is fly just above the height of the vehicles. He can raise and lower that depending on the environment that you're in. If you wanted to get greater context of taller vehicle, anything like that. So he's got that locked in. Now Dave is going to set the boundaries. Very simply, dropping a number of pillars all the way around your scene. 3D scan requires a minimum of 3 pillars. However, Dave is probably going to go around and set a number of pillars around to ensure that we have adequate coverage and to ensure that we're not encompassing anything that doesn't need to be in the capture. So while he's doing this, we're ensuring that we're getting distance away from the vehicle, but we're also getting all the detail that we need, but no additional that is unnecessary in that scene. So he's locking that in. Looks like we've got about 6 pillars now, 7, and then he'll be done here just momentarily. All right, so we've got a completed perimeter setup right there. Now, if Dave needed to, he could extend that volume outside of the realm of what he just dropped those pillars to. We don't need any additional area outside of that for context. So now we're looking at the strict geofence. So if we had active traffic nearby or active traffic overhead on an overpass, we could set those various ceilings, floor, or the wall to ensure that the drone doesn't pass outside of that space. Dave's got a safe distance of about 2 meters away from the vehicles and from the other surfaces there. He can set that up or as low as he needs to ensure that the drone stays away from potentially blowing away any evidence, with a prop wash. So we're going to leave those geofences off. He's going to move right into the review suggested augmented reality observer point. Very easy to do. The drone's going to go and give us a quick glance of where things are at. You can also set it manually for your preference and be able to see that view of the entire capture area while the drone is flying. So now that he's got that set, we're going to go right into begin exploration phase. This is the point where the drone is going to fly around the crash scene and start building a mesh and making calculations and decisions on how much data we need to capture to achieve the ground sampling distance we need for the level of detail that we want in our final rendering. So now the drone's nearly complete doing that. We've got a little printout here that shows us the drone is going to capture about 66 photos, 1 battery flight time, and we can go in and change any of those settings. We've got 1.6 millimeter ground sampling distance. That was in that top corner. So if we needed to, we could adjust that. Dave can also dial that distance to surface up and down to change that ground sampling distance. We've got good 70-80 overlap in that middle figure there. That's typical for most crash scenes. You could even bump it up as high as 90-90 if you needed to, but Dave can keep that down at 70-80, and we'll have adequate coverage for our model here. Again, you've got the option to click on those strict ceilings, strict floors, strict walls for those geofence in case you've got active traffic in another lane adjacent to you and you want to make sure that drone doesn't fly over there where it doesn't need to be. And then obviously your safe distance. We also have the option going on further down to adjust our speed. Right now at 2.5 meters per second, this is probably typical. You could even lower it down a little if you needed to take a little bit more time in between those captures. And then you can also change your Z-axis pitch, your Y and your X contour slicing within that scene. So if you've got a lot of vertical surfaces like the side of a semi or anything like that that you want to capture, or the top side of a vehicle in particular, there's additional evidence up there that needs captured, you can turn those on or off. And then rolling down a little further, taking best photo. I think this is always kind of a no-brainer, but you can set this for stop for photo as well. And I think having stop for photo option there, that gives you a little extra clarity on each one of those photos if you decide to set that. And that's going to help keep a clear image of your final rendering. And then obviously the camera field of view, if you want to use wide or narrow, this is good for close-up inspection and a faster scan with the wide angle setup here. So I think we're all set to go. Dave's going to hit begin on the scan. So now the drone is going to start doing its initial pass. The drone will actually start to make a circular pattern around the vehicles, capturing that area. And as you can see, that yellow mesh is actually changing colors now. It's starting to go from yellow to green to blue, and then eventually it will change that color up to purple, showing saturation of photos in that area, ensuring that you've got good coverage within the boundaries that you set earlier with those yellow pins. And as the drone is going around, we're already moving through, we've got about a third of the photos already captured. X10 is extremely fast, and so is X2 and S2 at doing this 3D capture. So the platform works the same on all of our drones. Very easy, very safe, and this ultimately saves you time, and time is money. We all know that. So clearing the crash scene and getting a fair and accurate representation is the most important component here. And then obviously officer safety and the safety of all the first responders that are affected there in that crash scene. We want to ensure that we're minimizing the time that we need there to capture the data and get good quality data at that for our final rendering. Ultimately, this data could go to court, and we want to ensure that we have accurate representation of that crash scene. So right now the drone is starting to make its final pass to get around. Once it completes this final run here, it will make a 90-degree turn and start making continuous lawnmower passes in the opposite direction, or actually at a 90-degree direction to where it's traveling now. So all the while this is going, Skydio Autonomy is acting in the background at the same time. But there are 6 4K cameras, 3 on top, 3 on bottom of the aircraft, that ensure that the aircraft is staying safe away from objects with a 36-inch obstacle avoidance. This is all done in the processor while it's also capturing all this data and categorizing it with the correct telemetry, GPS information, and ensuring that we're getting good, accurate coverage and good overlap of the area here. We can see now that we're reaching near total saturation, there's just a few little areas left that have not had a photo taken, and the drone is still going at it here. And we've got just about 10 photos left here, and then it'll be sped up here in just a moment. We'll be done, and then we'll see that we've got a good model coming out of this momentarily here. One of the great things that has come out here with X2 and X10 is that we've got the ability to ensure that we've got coverage after we complete the scan, so that you're not returning to the office later on to do your final orthomosaic and discover that you've got voids. And we've got ability now to build a model right on screen and be able to determine, did we get adequate coverage? Do we have everything we need? So now that we're at this point, Dave has the option. We've completed the automatic run of photo collection. Dave has the option to take manual photos. If he needed to, he could select that and zoom right in and maybe get license plates or additional crush damage, or look inside. And there's Dave giving us a wave. Dave, I think we're done. We've got everything we need for this rendering. If you want to go ahead and land, and let's have a look at the model when you get a chance, sir.
Matt, I just want to jump in for a second,
Sure.
just to make sure that everyone's aware. Dave wasn't actually manually flying any of this. 3D scan makes it possible that once you've set your settings and how you want your scene captured, it does it all autonomously. So you don't have to be an expert pilot. You don't have to sit there thinking about every single image that you want to take. You kind of just set everything up and then let it go. And then once it's done, you can bring it back and process this onboard model, which is what you're seeing on the screen now.
Yep. So 3D scan, definitely to Noreen's point, this enables crash and crime scene reconstructionists and anyone that wants to collect data quickly and get an accurate representation of that data. It's an automated process, 14 steps following the cues on screen. Lock in your points where you want to capture, and you're basically capturing that volume and doing so very quickly. And it's super easy to use. Anyone can use this.
Matt, I'll ask you a question that came in. So how do the side lap and overlap impact both the speed and the quality of the data that we're capturing?
Certainly. So side lap and overlap goes into your ground sampling distance calculation. Side lap and overlap is that overlap between photos from side to side, and then your overlap from the front to rear in each one of those passes where the vehicle is making overlapping photogrammetry so that we've got good coverage, all ensuring that we've got detail in every crevice of those vehicles and on the side, particularly in the crush damage area. We want to ensure that we've got the highest ground sample, or particularly the lowest number in that ground sampling distance, ensure that we've got really good coverage and that the detail in our final rendering is very crisp and can be interpreted by anyone at a courtroom.
Excellent. I know you're doing a lot of work with different crash teams across the country, and they're trying to incorporate drones into their workflows now. How do you see that working for them with the traditional methods that they're using, whether that's they're still using the old roll-a-wheel and measuring like that, or they're using total stations? How are they bringing drones into their workflow?
Sure. So drones are very rapidly entering the workflow of crash and crime scene across the country. They're finding that the traditional methods of measurement, while they are absolutely accurate, they take a lot of time, and time is of the essence, especially when evidence can decay right on scene. If you've got weather rolling in or the temperature could be affected, could affect the scene. You also have active traffic lanes and the extreme risk of high-speed secondary crashes that can occur at the back end of a traffic backup. So there's a lot of pressure on crash scenes, reconstructionists that need to get that scene documented quickly, accurately, and then get the roadway clear so that we can get traffic moving again and prevent those secondary high-speed crashes from occurring. So a lot of the traffic crash reconstruction units are really taking to drone photogrammetry, and they're seeing the benefits of doing 2D and 3D capture to get those scenes documented quickly and accurately. And they're finding that the results on the other end are highly accurate. They can measure within those scenes, and we can speak to the accuracy of this as we go along here. But Dave's got our image pulled up already. Just take a look at this. We can see that we've got a really good looking model between those two vehicles. We can see all the crush damage on the front end of those two vehicles, and we're able to see all the angles from which those shots were taken within that scene, and we can measure within that scene if we need to using a post photogrammetry engine.
Yeah, I think it's really onboard modeling is super exciting, right? You can see exactly what you've captured before you leave the scene. With a lot of other technologies out there, you've got to kind of cross your fingers and take that data back to your computer or back to the office and then process it and then hope you got everything that you need. But in this case, you have the ability to confirm before you leave the scene that you have everything you need. And if you don't, you can just go ahead and fly initial scan or add extra images to what you have there. That looks great, Dave.
Great job, Dave. Yeah, we've got being able to manipulate this model at the very end of the scan is a real time saver here, and it's a very assuring component that we've got all the data that we need before we leave the scene, because once you tow these vehicles and disturb the original context of that scene, it's very difficult to go back and get that level of detail. But now with a completed model, we know that we've got everything we need within the scene, and we can reasonably go ahead and tow these vehicles and get them out of the way, get traffic moving again, and we can go back to our office and be able to load that data into a post photogrammetry engine of any type, because our data is agnostic. It can go into any engine, and we know that we're going to get a high quality orthomosaic or 3D model that we can use later on for prosecution or validating who's at fault, or if there's no fault in this, at least be able to make that determination.
Yeah, and I do want to add with this onboard model, what you're seeing is a textured mesh that is created right on the controller for the X10. That is the drone that Dave flew for this data capture. And if you wanted something that was more of a point cloud or something that you could do a little bit more with to, use it in animations or use it in other kind of types of reconstruction, all you're going to do is take these exact same images that he captured in the 3D scan and then take that into your photogrammetry engine of choice. Additionally, and I know that you had mentioned crash photogrammetry, on my travels with law enforcement agencies across the country, I feel like a lot of crash and crime scene teams are limiting themselves to just the 2D images from a drone, which is great. You can get yourself, a stitched together orthomosaic image that can stand as a basis for your 2D diagramming, but you're really missing a huge portion of the deliverables you could be making for court by just using these images in their 2D form and not converting them to a 3D point cloud or a model, such as what you're seeing here. So a lot of other things, and we're going to go through some of those here in a moment, what you could be doing with these images if you aren't already thinking about it. But this onboard model is, new and unique to Skydio and something that we're all really excited about. So you could take this off of the controller, off the drone, and then you could place that into additional forensic software to complete your diagrams or whatever else that you're looking to do.
Yep. To your point, Noreen, we definitely are seeing a lot of crash and crime scene sticking to just using that two-dimensional capture when you've got three-dimensionality here and capability to get that full context of the scene. And there is nothing more important than being able to, at the end of the day, if this goes to court, being able to show a judge and jury and walk them through that scene and literally having the ability to fly through it and show them in full rich detail all the side angles and everything that's happened at that scene, not just a bird's eye view from directly above. So the benefit of 3D scan is that you have that oblique angles, the very sides where the crush damage occurred, and that's the most important thing, to give the judge and jury a fair and accurate representation by giving them that three-dimensional analysis there.
And I do think drones have been embraced a lot more, I guess I should just say, with crash teams than they have with crime scene teams. And as much as I loved kind of hanging out the side of a helicopter to photograph an officer involved shooting or a homicide investigation that was out in the desert, to take images of it, drones are really just more efficient and effective. And, it's not this big scene to kind of get up to your air unit and get into the helicopter and get to that scene and everything else. So a lot of crime scene units are now really incorporating drones into their toolbox as well, just for this exact same thing, right? You're flying it at outdoor scenes to capture your data quickly. Think about, a long shooting investigation that spans a long stretch of roadway or maybe blocks. You've got kind of just cartridge cases everywhere. It's really easy just to fly that drone, capture this data. And within minutes, you saw how quickly we were able to capture both of these vehicles. But within minutes, not only have all of those images captured, but also to be able to create the model like you're seeing here on your screen.
Yeah, we're seeing a lot of the crash units out there adopting the drone mentality and getting the quick capture, getting good data. And we're also finding that it's affordable at the end of the day, because you're saving time, saving money, and you're saving resources of your agency and those of other participating agencies, and getting folks out of harm's way out on the road and ensuring that the traffic keeps moving, but while at the same time getting accurate data that we need to be able to recreate those scenes in three-dimensionality. And so these crash units are adopting the drone model and using that. We're also seeing a lot of use of that data to be able to get the results that we want.
Matt, I know you do a lot of work helping our agencies get up and running with this. Can you just speak to the training that you think is required for 3D scan? Is it something that anyone can kind of learn in just a short training session, or is it something that needs a lot of technological understanding and a lot of practice, and it's one of those things that, use it or lose it kind of skills?
Sure. So 3D scan is really easy to learn. It takes just a matter of minutes to learn the walkthrough of the menu and be able to understand how those changing those ground sampling distance values can get you the greater detail that you need. So most people could relatively pick up a Skydio controller, turn on 3D scan, and be up and operating within the hour and really have a good understanding of how it works. It is really simple to use. I would put it at just as easy to turn on your camera on your iPhone and be able to go start snapping photos. It's very easy to follow that menu and understand how it's going to achieve the values that you need and create those models, and really speed up your investigation and have quality results that you can depend on at court time.
Yeah, you touched on this earlier, but some of the questions that I used to get all the time were, what is the overlap? What's the side lap I need? What's the percentage I'm looking for? And you could see in 3D scan that it was kind of automatically giving you a starting place for that. You could obviously bump that up if you wanted more. You're just going to get more images. It's going to take a little bit longer. You're going to have a little bit better quality. But the software itself, after it kind of goes through and it sees what the scene looks like, it's basically telling you, like, these are the suggested settings for it. And those are sufficient, more often than not. It just depends, if you want to spend a little bit of extra time and have more images captured.
Sure. Those are settings between I would say the X10. We'll talk about that on first. X10, you can set those settings right at a 20, anywhere from a 10-foot to 20-foot standoff of your subject, and be able to have 70, 80 overlap. You can go even higher than that for a 2D capture to get that data. The ground sampling distance ultimately is the distance across 1 pixel on your display view, and ensuring that you get a really close value on that. You want to be able to set that ground sampling distance somewhere in the 1 to 2 range, 1 to 2 millimeter range. It's very easy to do. If you need greater detail, you can really move the drone in closer and be able to get those very small ground sampling distance numbered all the way down to 0.64 millimeter if you need to. So it's really easy, just by changing your side lap, overlap, and then also the distance from the drone to the subject. And those 3 values are what affect your ground sampling distance. And by doing that, you will increase the number of photos that you capture. However, you're going to get a greater level of detail. It all depends on how much time you have available at the scene. You may be capturing a scene like what Dave was there, and the sun's about to set, and you need to utilize the available sunlight that you've got to illuminate your scene. If you don't have any artificial light to be able to put on those vehicles, if you've only got 20 minutes, work within that 20 minutes and set that scene up to capture. And the drone will tell you right on the menu an estimation of how many minutes it will take to fly that mission. And once you set those mission parameters up, 3D scan takes over and does all the work for you. And while you're there holding the controller, you can be also doing other tasks if you need to, or paying more attention to your surroundings, officer safety, or directing resources while you're within that scene. As a controller and pilot of that scene, you also have the option to pause the scan and be able to go handle, if you need to allow people or vehicles through your scene, and then you can re-engage that scan and hit play, and it will pick up right where it left off. The same goes for a battery change. Very easy to do. Pause the scan, land the drone, save your data that you've collected thus far, swap your battery out, and restart, and the drone will pick up right exactly where it left off in the middle of the scan and be able to continue mission. So 3D scan is very intuitive. So no matter what part you're in, it will pick up and go right back into its scan management.
Excellent. Some questions in the chat about the availability of 3D scan, and you can use that on your X2, your S2, or X10. However, the onboard model, which is what you saw processing after the 3D scan flew, that is only available on X10. So hopefully that clarifies some questions there. Kendall, can we go back into the slide deck and we'll just talk through some of the courtroom deliverables? So again, we see a lot of agencies kind of just going out, capturing these images, and then they're creating one collective 2D orthomosaic image. And that's great. And that works kind of as an updated satellite image for those of us who used to import Google Maps to create diagrams. But there's so much more that you can do with it for courtroom purposes. So I do want to talk through this quick scene. This is a mock scene that was provided to me from John, if you're out here, thank you, over in Chicago. And this is a mock crime scene that they put together. So you'll see what you were seeing prior to this were the images that were captured. I believe it was 305. And this was actually with the S2 Plus, so with our smaller little blue drone. And I took all of those images and I imported them into FARO Zone 3D Expert software. And at medium quality, because there's different quality you can choose, it took about 50 minutes for my computer to process all 305 images into the point cloud that you're seeing on your screen now. And then I just created a quick fly through so I could show everything that was captured for this particular instance. And so you can see the evidence placards, you can see the vehicles. He even added some evidence placards there into the inside the vehicle, as well as there's one kind of tucked in underneath the front of the vehicle, the front right corner. So you can see all of those really well. And this was all just captured with 3D scan. So he set up his the scene, he set up the parameters just like you saw at the beginning of this live demonstration. It went and it did its thing and it came back and he had the 305 photos. So that's great. You can have this 3D point cloud. You can create a fly-through video like I did here. You can set up perspectives if you needed to. So if there were conversations about what someone could or couldn't see, you would be able to show that because now you have a 3D environment from those 2D images that were captured with the drone. If we go to the next slide, Kendall, real quickly, I just pulled out some measurements. Now, when I processed these images, I just did it based on the GPS coordinates that are built into the images when they're captured. And then I was told, that they had placed down these essentially ground control points. One was at 50 feet distance and the other was at 25. So real quickly, I just pulled a measurement in the software to see how close I was to their known measurements. There's other ways that you can scale your point clouds. You can do it by known measurements in images prior to processing. You could bring in ground control coordinates from total stations. There's all different ways that you can do it. I just did it the easy way. I did it based on the GPS, and these are the measurements that I got from that. In the next slide, you can see that I took that point cloud. I think I spent less than 5 minutes. I traced over some of the lines. I kept the measurements on there. I threw in some evidence placards and some vehicles, and within minutes, I had a 2D diagram, that I could throw in the case file, because no matter how technologically advanced we seem to get, we still just want this 2D diagram for court. So you can see that same thing here. And this was just by tracing over the point cloud that I had in the software. We are agnostic, so you can bring our images into any photogrammetry software. You could then take that data into other forensic diagramming software. I am a diehard, long-time CAD Zone, Crime Zone, FARO Zone user, so that's just my choice when I start creating my deliverables. And then I think we have one more slide here, Kendall. Oh no, just the Q&A. So just kind of an example of the deliverables that you can make with just capturing these images and the 3D scan. Looks like we have a question, and Matt, I don't know if you want to take this or we can talk about this together, but how do you manage the photos and the data? Does Skydio integrate with other evidence platforms?
Yeah, so managing the photos and data, you've got several options to offload the data to your computer for use later on. You can use Media Sync if you've got Wi-Fi back at your home station, and that can be that's where the drone will actually upload through API connection right to either to your cloud or up to a third-party photogrammetry engine or to a file system. Perhaps you have Axon evidence.com, or you've got another photogrammetry service that is able to ingest all the photos. You also have the option to take the SD card right off the aircraft and put it into a card reader and load that locally on your computer. And then with that, once you have that data in a folder, you can use that those JPEGs in any post photogrammetry engines such as GNX, Pix4D, Bentley, any of those, they're all agnostic. Our photos are agnostic, and they can be imported in there. And then you also have a auto-generated CSV file that's included with those photos that you can help use as a key in some of those post-photogrammetry engines to ensure that you have the proper alignment of all the X, Y, Z axis, everything, all the telemetry data that is ingested in with those photos. And then looks like we have another question here. Does the 3D scan require a subscription? Well, 2D map capture is included with X10. It's part of your operating system on X10. However, if you want the benefit of 3D scan and a lot of the other capabilities that come with that, that's all in part of a 3D scan subscription, and you can reach out to us for pricing on a 3D scan subscription, and those come in 1 and 3 year packages.
Excellent. I think we'll take 1 or 2 more questions. So if you have them, go ahead and drop them in the chat. But the question was, are we compatible with Pix4D or Bentley software? And the answer is yes, we're agnostic. So the images that you're getting from the drone, you can put those into any photogrammetry software and process them however you choose. And then if you were taking it out of that software and then putting it into any kind of forensic software for diagramming, that will work as well. Let's see, what else do we have here? I think that might be it. 5 minutes early.
All right.
All right. Well, Matt, I really appreciate your time and all of your insight for using drones for crash documentation. To Dave in the background, thank you so much for all of your help in flying for us today. We really appreciate it. Like I said, you will receive a link with all of these images post webinar once I get those, and you can do with them what you want, see how it works out for you. So if you want to go process those into photogrammetry software, if you want to create an orthomosaic, can't get my words out today. If you want to, do an analysis on the crush that you're getting from the vehicle there, you could do that as well. So more to come there, and hopefully this was helpful so you can understand a little bit more about how Skydio products are helping to capture crash and crime scenes. We really appreciate you hanging out with us today. Matt, any final words?
Well, we're always available to take questions later on. If you've got questions, particularly with 3D scan or how you can utilize our drones in your workflow to get better accuracy, faster results, we're always here to help. Thank you, Noreen. Appreciate your time.
Yeah, absolutely. All right. Thanks, everyone. Take care. Stay safe.